Assalamualaikum warahmatullahi wabarakatuh. We are from group CDCS 267 2B1 and today we are going to present our linear algebra project which is about least square solutions and best fit curve. So our group has decided to choose a study case about hand, foot, mouth disease from year 2012 until 2021. Firstly, let us introduce ourselves. Our group consists of 3 members which are Aisyah Kamilah binti Mahasan, Nur Ain Arisa binti Abdul Samah and Nur Izliana Hamizah binti Abdul Halim. Alright, so moving on. For the introduction, in Malaysia, hand, foot and mouth disease HFMD significantly affects children, with boys consistently experiencing higher incidence rates compared to girls. Annual epidemiological data reveals that boys typically constitute about 60% of cases each year. This persistent gender disparity may be due to behavioral factors such as boys engaging more in physical play, increasing virus transmission risk. Understanding these yearly trends help tailor public health intervention like targeted hygiene campaigns in school to effectively reduce HFMD cases. By tracking and analyzing gender-specific data annually, health authorities can assess intervention success and adapt strategies to control the disease spread among higher risk groups. Alright, so our study cases is about gender ratio and total cases of HFMD from 2012 to 2021. So this is the table for the data that we have already obtained.
Next, I would like to discuss more about the implementation and graph of quadratic model. The information demonstrates the quadratic polynomial equation b at a plus bx plus cx squared equals y. The matrix representative of the above system is by using m multiplication by v equals to y, which is normal equation. Next, we find the least square solution by multiplication of matrix transpose M with matrix M, then multiply with matrix V equal to transpose of matrix M with matrix Y. From that, we will get A, B, and C. Next, we find error vector by using formula E equals to Y minus MV. Then we get the list of the value of a vector. Then we find the magnitude of elevator by using the formula. For the next slide, show our graph of a quadratic model. We point this get data and we got the best hit curve that we have calculated manually, and as you can see there is a picture, we got a curved line.
So for analysis, we can conclude that based on the quadratic method above, the error magnitude in the approximation are obtained, which is type of the best fit curve is quadratic and the error magnitude that we obtain is 8092.64. So in conclusion, the best quadratic curve in this case is based on the quadratic method described above, as the equation and graph can be constructed with minimal error in terms of magnitude.
Assalamualaikum. So next, I will explain about the method. First, we provide data consists of two lists X and Y, which appear to represent the gender ratio X and the number of reported cases Y of hand, foot and mouth disease. The gender ratio in this X is expressed as a decimal, where each value might represent the ratio of male to female cases. For instance, a value of 1.53 would suggest that for every 1.53 males affected, there is one female affected, indicating a slightly higher incidence in males. The scatter plot generated from these two lists would visually represent the relationship between the gender ratio and the number of reported HFMD cases. Each point of the scatter plot would correspond to a pair of values from lists X and Y, with the X-axis representing the gender ratio and the Y-axis representing the number of cases. In this context, we have a data set represented by a matrix A and a corresponding 10 elements column vector Y and 3 elements column vector Z. The matrix A is the structure to facilitate the fitting of the quadratic equation of the form A plus Bx plus Cx squared to the data where A, B, and C are coefficients to be determined. The first column of A consists of ones, which is common practice when including an intercept term in a regression model, and the second column is represented by B, X, and the third column is Cx squared. By using a least square regression approach, we can determine the values of A, B, and C that minimize the sum of the square difference between the actual Y values and the values predicted by the quadratic equation. First, we will calculate the transpose of matrix A and assign it to the variable A3, and then compute the product of the transpose of matrix A with matrix A itself and assign to the result to the variable R. And third, calculate the product of the transpose matrix A with a vector Y and assign to the result to the variable S. Next is find the inverse of the matrix R, which is the product of A transpose A, and assign it to the variable T. To find B, we compute the product of the inverse R, which is matrix E, with vector S, and assign the result to be variable B. And then we calculate the product of matrix A and vector V and assign the result to the variable X. This vector X represents the least square solution to the system of equations. Next, we will find E, which represents a vector of error, by substituting vector X, the least square solution from vector Y. And lastly, we will find the magnitude of error.
So after we have done all of that, we can find the plot or the graph of our equation. And we can also combine it to the scatter plot that we have found at the first place. So that is our graph for this study case. So that's all from us. Thank you very much and have a good day. Bye bye.